Welcome student to MJC Learning. I am going to teach thermodynamics. Thermodynamic is a combination of two words. Thermo means heat and students dynamic means motion. So we are going to study motion of heat. Thermodynamic is a branch of physics that deals with the concept of heat and temperature and the interconversion of heat and other form of energy. Let us take some example of heat to mechanical work conversion, which is steam engine. In steam engine, steam pushes the piston and piston rotates the wheel. Next is example of mechanical work to heat conversion. When you rub your palm can experience some heat in between them. Rubbing your palm is mechanical work. So here mechanical work is converted into heat. Next is what we are going to study in thermodynamics. First is a thermodynamic system. There are three categories of system. First is open, closed, and then isolated. This thermodynamic system will have some state in which they stay. Those will be represented by thermodynamic variables. Just like a point in a graph is represented by x, y, z coordinates, state of the thermodynamic system will be represented by pressure, volume, and temperature. Next is thermodynamic process. Now, as the system will be in some state, it will be wanting to move to some other state. Then a process is needed to be done on that system. Example, if we keep its pressure constant and change its volume and temperature, then it will be called as isobaric process. There are many processes which we will be discussing later. Now these processes are governed by certain laws of thermodynamics, which is zeroth law of thermodynamics, first law of thermodynamics, and second law of thermodynamics. Last is application of thermodynamics. Refrigerators, heat engine, and their efficiency and working. Now, talking about thermodynamic system, a thermodynamic system is a part of universe under thermodynamic study. Students, be careful this time, okay? Careful while hearing. System is a part of universe under thermodynamic study. Now, what is this thermodynamic study? We will be changing its pressure, volume, and temperature, and we will be studying the system. And remaining all part except system of the universe is called surrounding. Depending upon the interaction of system with the surrounding, there are three types of system: open, closed, and isolated. Let us consider an example. Water in a vessel kept on a table. Water is a system, vessel is a boundary, and rest of all including table is called surrounding. Now if in the place of table, if a burner is placed, heat from the burner will be transferred to the system. Okay student, I am going to repeat it again. Now if in place of table, if a burner is placed, heat from the burner will be transferred to the system, and here our system is water, and water when heated will start to boil and steam will form. What we are observing here is that system is exchanging heat as well as matter with the surrounding. Such type of system is called open system. Here matter here is steam. If we place a lid on the vessel, then steam will not be able to escape the system, and only energy will be exchanged with surrounding. Such system is known closed system. And if system is not able to exchange neither heat nor matter with the surrounding, such system is called isolated system. Open system, heat and matter is exchanged with the surrounding. Closed system, only heat is exchanged with the surrounding. Isolated system, heat not the matter is exchanged with the surrounding. There is no perfectly isolated system in the universe. Okay. The boundaries also can be of two types, adiabatic and diathermic. Adiabatic does not allow energy to exchange in the surrounding, whereas diathermic walls are heat conducting. What is thermal equilibrium? When two objects are at same temperature, they are in thermal equilibrium. When you put a piece of ice in water at room temperature, the ice melts. This is because the water at room temperature transfers heat to ice and helps ice melt. In this case, we notice that ice reaches a stage where there is no more transfer of heat. This no more transfer of heat is called thermal equilibrium. The concept of thermal equilibrium is very important while studying Zeroth law of thermodynamics. So again I am going to repeat the statement of thermal equilibrium is when two objects are at same temperature, they are in thermal equilibrium. So next topic is our Zeroth law of thermodynamics. If two systems are each in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. Let us take an example of it. Let us consider three systems A, B and C. If A is in thermal equilibrium with C and if B is in thermal equilibrium with C, then A and B are also in thermal equilibrium. Now next topic will be internal energy, how internal energy will be changed, first law of thermodynamics and different processes. Thank you.